I want to talk today about looking at a problem where we deal with a mixture of gases. And in this particular problem, we're looking at a mixture that contains 0.188 moles of O2 and 0.563 moles of methane. And the mixture has a total pressure of 795 torr. And what we want to know is the partial pressure of each gas. And there are generally a couple of ways that you can do problems like this. The easiest way in this particular case is to look at the mole fraction of each gas. And if we do that, the definition of mole fraction is the ratio of moles of whatever gas we're looking at over the total moles of gas. So in this particular case, the moles of, if gas A were O2, the moles of A would be 0.188, and the total moles would be 0.188 plus 0.563. Now, the reason that we can get pressure from this information comes from something we notice if we look at the ideal gas law. And if we do this, what we're going to notice is that pressure and number of moles are directly proportional to one another. So we could replace the moles of A here with the pressure of A and the total moles with the total pressure and get this relationship. We can rearrange, so the relationship that we're going to look at is the mole fraction is equal to the pressure of A over the total pressure. We can rearrange this a little bit. If we want to solve for the pressure of A, that's going to be equal to the mole fraction of A times the total pressure. And that kind of makes sense when you think about it. The pressure of A is the total pressure times the fraction of the total moles made up by A. So anyway, when we go and do this calculation, first thing we need to do is find the mole fraction of each of our two gases. And we can do that. Oops. Let me just pull the stuff out here. So for oxygen, it's going to be the 0.188 moles of oxygen we have over the total moles, which is 0.751 moles. And we could do the same calculation for methane, 0.563 in the case of methane over 0.751 moles. Or we could recognize the fact that if oxygen has a mole fraction of 0.25, the two have to add up to 1, so methane has to be 0.75. Now we use this relationship between the pressure of A, the mole fraction of A, and the total pressure to find our partial pressures. And when we apply this equation, just let me move it, oops, move this equation down so we can look at it. When we apply this equation to oxygen, we see that the mole fraction 0.25 times the total pressure gives us 199 torr. That's the partial pressure of oxygen. I could do the same thing for methane, multiply 0.75 times the total pressure, or I could recognize that the total pressure of the two has to add up to 795. So if the partial pressure from oxygen is 199, the 795 minus the 199 gives me 596. If you don't believe that, take the 0.75, multiply it by the total pressure 795, and you're going to get the same number, 596.